Hi, 8th grade. We're going to just go through this table, the phases of change. So if you go from a solid to a liquid, that's melting. That's heat going into the solid as it melts. Liquid to a solid, that's when you have freezing. Heat is leaving the liquid as it freezes. Liquid to a gas, vaporization. This would be boiling and evaporation, and heat goes into the liquid as it vaporizes. Gas to a liquid is condensation. The heat leaves as it condenses. Solid to a gas is sublimation. That's when the heat goes into the solid as it sublimates. And if you want to try an experiment, put a cup of with an ice cube in it in your freezer and check back in 3 weeks, and you should notice that your ice cube has gotten smaller or disappeared, and that was sublimation. Okay, we will skip that part. So this graph, this line graph, is showing you phase change. So here we have a solid, and as you increase the heat energy, it melts, okay, and the temperature increases. And then we have a liquid. As that temperature continues to increase and we have more heat energy, it vaporizes. Oops, I lost my mouse. And then it becomes a gas. Now, when the gas and the heat energy starts to get less, okay, then it starts to condense. Then you have less heat energy, lower temperature, it becomes a liquid. Then it freezes, and then you have a solid. So note that freezing and melting points are actually the same temperature. It's not something we think of often. Also, the horizontal lines here are indicating that there is no temperature change at that point. And the diagonal lines, meaning depending which way you're going, will mean an increase or a decrease in temperature and heat energy. Okay, let's move on. Contracting and expanding during phase change. You have heating liquids and solids. The particles move faster, and this faster motion causes the particles to move apart, resulting in expansion. Contracting and expanding during a phase change is when you have cooling liquids and solids and the particles are slowing down. The attraction between the particles pulls them close together, causing them to contract. So, heating up gases inside a balloon, the particles will move faster. The particles hit inside of a balloon more frequently with more force, and the result in higher pressure inside the balloon than outside. And this is causes of expansion of a balloon. Cooling gases inside a balloon will slow down the particles. The particles hit inside of the balloon less frequently, thus it's also with less force, resulting in a lower pressure inside your balloon and causes the contraction of the balloon. Okay, for those who have been doing remote, please do the drag the correct box to the phase change diagram. And that's where we will stop.